Here we see some square roots of negative numbers, which are not real numbers. In fact, these are part of our applications of complex numbers. One of the properties that we have is that the square root of a negative, so let's just say in general the square root of negative a, is equal to I times the square root of a. So this is an important property because it allows us to rewrite this in terms of something that is a real number, namely the square root of a. So these numbers like the square root of negative 27 and the square root of negative 48, those are not real numbers, and we cannot apply any real number properties to them. So any of the square root properties that we're familiar with do not directly apply to them. So whenever we see a square root of a negative, the very first thing we need to do is write it in this form so that we get I times square root of a, and that way we can use our square root properties that we know to work with that square root of positive a. So this form, basically what happens is that negative sign comes out in front as an I. And so what we get here is we have I times the square root of 27 plus I times the square root of 48. Neither 27 nor 48 is a perfect square, so neither of those is going to work out exactly, but we might be able to simplify them. So if we look for perfect square factors of 27, we find that 9 goes into 27. 27 is 9 times 3, and 9 is a perfect square. And for 48, we have that 16 goes into 48, and 16 is a perfect square. 48 is 16 times 3. So then using our product rule for square roots, we can separate each of those. So it's I times the square root of 9 times the square root of 3. So we can do the square root of each part separately. Similar in our second term there, we get I times the square root of 16 times the square root of 3. And that way we can work out those parts that work out nicely. So the square root of 9, that's 3. So I have I times 3, or 3I square root of 3, plus the square root of 16 here, that's 4. So I have I times 4, or 4I times the square root of 3. Then those two terms happen to be like. They both have the I, and they both have the square root of 3. So I have 3I square root of 3 plus 4I square root of 3. That makes 7I square root of 3. So that would be the simplified form of our answer.